Cranes are useful tools for moving heavy objects in industrial, construction, oil and gas, and other work sites. You might already be familiar with the cranes you use in your work area, but there are still risks to working on or around cranes. An unstable load, a misinterpreted hand signal, lack of experience, lack of maintenance, and infrequent inspections can all cause crane accidents. Cranes carry heavy materials such as stone blocks, scrap metal, sheet metal, and other building materials, so crane accidents often result in severe injury or death to those in the area. It's important to know how cranes work and what hazards they pose so you can keep yourself and your coworkers safe around them. When you've successfully completed this course, you should be able to identify types of cranes and the types of inspections required on cranes. You'll also be able to identify employee roles and hand signals during crane use, safe practices for rigging and loading, and types of crane attachments. While this course can provide you with a good overview of the basics of crane operation, it does not certify you to operate any specific type of crane. You'll require hands-on training over the equipment you'll be using and the hazards and characteristics specific to your work site. Lesson 1. Identify types of cranes. Overhead cranes generally move along an elevated runway system of long beams along the length of a facility. Overhead cranes consist of three important parts: the hoist, which lifts loads up and down, the trolley, which moves the hoist from side to side, and the bridge, which moves the hoist and trolley back and forward. This setup lets the motorized hoist move up and down the length of the room and back and forth across the beams, carrying anything attached to the chain with it. A gantry crane is a lot like an overhead crane. Gantry cranes also have a hoist, trolley, and bridge, but instead of two long beams that run up and down the building, the bridge rests on wheeled uprights. It looks sort of like a swing set, but with wheels on the ends of the legs. The motorized hoist is on the top. Gantry cranes generally operate on set runways or tracks on the work floor area. Gantry cranes are portable in that they are not permanently fixed to a building or structure. Usually, gantry cranes are smaller than overhead cranes, though very large ones are used in shipbuilding and other construction projects. Some cranes are controlled from a cab attached to the crane or from an operator station nearby, but others are controlled with a hanging pendant that can be used from the floor underneath the crane. Pendants can either be attached to the crane or hoist by a cord or via wireless radio controls, depending on the specific crane used in your facility. This allows the crane operator to control the crane from any point below the bridge, allowing them to get a better view of the load as needed. These cranes pose many of the same hazards as stationary cranes. If you'll be operating a pendant crane, you'll still need the help of a rigger to provide hand signals while you move the crane. Also, if you're operating the crane from the floor, never stand directly under the load while it's suspended off the ground. Mobile cranes are similar to other types of cranes with the additional ability to travel around the job site and adjust the boom's length and angle. There's a large variety of mobile cranes and hoists that you could work with, but we'll focus on three common, versatile types: crawler cranes, truck cranes, and wheel-mounted cranes. A crawler crane consists of a rotating superstructure equipped with a power plant, operating machinery, and a boom, all mounted on a vehicle equipped with crawler treads and is useful in rough terrain environments and in different weather conditions. Truck cranes have the same basic equipment, but are mounted on an automotive truck and can lift varying sizes depending on the size of the vehicle. Wheel-mounted cranes also contain similar equipment, but are mounted on a base or platform equipped with rubber wheels for travel. Wheel-mounted cranes often look similar to truck cranes, but they're generally much larger, usually with 12 or more wheels. Lesson 2. Identify required crane inspections. Because cranes can carry such heavy weights, they must be inspected regularly. The Occupational Safety and Health Administration, or OSHA, requires two varieties of crane inspections: frequent and periodic. Frequent inspections take place at daily to monthly intervals. while periodic inspections take place monthly to annually. Pre-shift inspections and maintenance inspections are two types of frequent inspections. Pre-shift inspections spot obvious problems with the crane before a load is ever lifted. Maintenance inspections are generally performed weekly or after critical lifts that are close to the crane's capacity. Your company should have procedures in place for all inspections, including checklists and documentation procedures. However, you should always be on the lookout for potential damage and mechanical problems, even if you notice them outside of a normal inspection. Before you begin putting your crane to work for the day, you'll need to do a pre-shift inspection from the floor, including the hooks, pulleys, cables, hoist drum, hoses, hydraulic equipment, and control mechanisms. Keep the control station clean and make sure all labels and warning signs are legible. All machine guards should be in place and undamaged. When checking the cables, look for kinks, crushed spots, and broken threads or sections. Also look for unwinding in the wire rope and separation from the rope core, also known as bird caging. Check the way the cable is winding onto the drum. It should wrap straight without overlapping itself. The safety latch should open and close the right way, and if the hook is bent open or twisted, get a new one. If you find anything wrong with the crane or any of its pieces, tell your supervisor and take the crane out of service until it's fixed. After visually checking the crane, operators should test the crane's controls and limit switches. Limit switches are safety devices that prevent the crane trolley from moving too far in one direction and the hoist from moving too high. Test these by moving the crane in all directions and raising the hoist until the limit switches trip. Also test the hoist brake and the trolley movement. If you're operating your crane using a pendant, make sure the cable is in working order, or that there is nothing that can interfere with wireless radio operation. If you need to replace parts or make any repairs, take the crane out of service until it can be fully repaired. Inspections are more in-depth inspections of certain crane components. Periodic inspections typically include the beams the hoist rides on, crane and hoist ropes, pulleys and drums, brakes and bearings, and even bolts and rivets. Annual load testing of your company's overhead and gantry cranes is a type of periodic inspection. OSHA requires that crane and hoist ropes be inspected by a qualified person at least once a month and must be certified with the date of inspection, identification of the ropes, and the inspector's signature. Rope inspection should look for unsafe conditions such as corrosion, worn or broken outside wires, loss of diameter, connections that are cracked, bent, or worn, and severe kinking, crushing, or unraveling. Close attention must be paid to areas where rope contacts sheaves, saddles, or limited rope travel areas. If a piece of rope hasn't been used in over a month, a qualified person must inspect it before it can be used. Generally, periodic inspections are not the responsibility of operators, but might be done either by your company's maintenance crew or outside contractors who specialize in crane inspection. Lesson 3. Identify employee roles and hand signals during crane use. With the exception of cranes such as pendant or radio-controlled cranes, most cranes are generally controlled from one spot. Since the crane operator is generally stuck in one location, there also must be a rigger present to connect the crane to the load and help direct the load. In most cases, the operator and rigger will be in voice contact in one form or another, but if electronic communications fail, the operator and rigger need to be ready to use a series of hand signals. The American National Standards Institute, or ANSI, has a basic set of hand signals that we'll go over, but your company may have additional signals to use. The crane operator should only respond to signals from the designated rigger, unless you or someone other than the rigger notice a safety problem. In that case, you should give the rigger or operator the stop or emergency stop signal. The first signal we'll go over is the hoist signal. With your arm bent at the elbow, point your index finger up and twirl it in one direction or the other. To signal for the operator to lower the hook, do the opposite of the signal for hoist. Point down with your index finger and twirl it around. To signal bridge travel and have the load moved up and down the room via the main beams, put your arm up with the hand extended palm out. Make a pushing motion with your hand in the direction the load needs to go. To signal trolley travel and move the load back and forth between the bridge beams, bend your arm at the elbow with your hand up, fingers closed, and use your thumb to point where the load needs to go. Some cranes may have more than one hook assembly known as a load block. If so, and if you're moving loads with more than one block, designate which is which before you start by numbering the blocks. That way, when you need to move block 1, the rigger can hold up one finger, then give you the movement signal for that block. If you're moving block 2, the rigger holds up 2 fingers and then gives the movement signal. To signal that the load needs to move slowly, use the normal hand signal for whatever kind of movement needs to happen, but then hold your other hand above or below the signaling hand to indicate extra care should be taken. Depending on what's being moved, an overhead crane could be using a magnet instead of a hook or some other type of rigging. In these cases, the operator needs to be able to tell the rigger when the magnet is disconnected, so the rigger can move the magnet away from the load. To signal the magnet is disconnected, just spread your arms with your palms up. Stop and emergency stop are the only commands that the crane operator should recognize and follow from anyone that isn't the designated rigger for the project. To signal stop, stick your arm out to the side with your palm down, fingers pointing out. Then wave your arm back and forth horizontally. To signal an emergency stop, put both arms out with the palms down and the fingers pointed out. Then wave both arms horizontally. Again, if you notice any safety concerns or potential problems with the crane or in the path of the load, give these signals to the operator or the rigger right away. Lesson 4. Identify safe practices for rigging, loading, and crane operation. It's important to rig loads properly. The first step is identifying how heavy the load is. Crane operators are responsible for knowing if the crane can handle the load before trying to pick it up, and operators and riggers can only decide the proper kind of rigging for the job if they know the specific weight. You'll need to check the load chart to determine the specific capacity for your crane's length and the angle the load will be lifted at, and you can use a dynamometer or a load cell to determine the weight. Once you've picked the right rigging, keep it in good working condition, and pad sharp edges to protect slings and rope. You can use wood, tire rubber, or other soft, flexible material to pad edges and keep the load from cutting itself loose. Other things that can cut rigging are eye bolts, shackles, or hooks that have been cut, welded, or brazed. Once you've got the rigging on and ready to go, try picking up the load just a few inches to make sure everything will hold. Before you try to lift anything, there are a few things you need to keep in mind. First, make sure that the hoist rope is not kinked and that multiple part lines are not twisted around each other. The crane or hoist must also be kept in a level, stable position. In many instances, you will need to do this by using outriggers, sometimes with supporting blocks. Supporting blocks need to be strong enough and in good enough condition to withstand the weight of the crane or hoist and the load you will lift. Outriggers are generally required when the load is far enough away from the crane or hoist that lifting it would exceed the manufacturer's loading recommendations, so it's important to know when riggers are required for each specific piece of equipment. When positioning the crane or hoist hook over the load, position the hook and lifting line directly over the load, so it will lift straight up. The hoist rope should never be wrapped around the load. Instead, you must attach the load to the hook using a sling or other approved rigging device. Cranes are designed to carry a lot of weight, but they have their limits. If you're a crane operator, you should be well aware of your crane's weight limits, but you can still cause accidents by picking up or lowering loads the wrong way. For example, lifting a load from an angle known as side pulling can cause the rope to snap and slip the load out of the guiding pulleys. Side pulling can also make the load swing wide from where you want it to be, and swinging too far wide could snap the cable or pull down a mobile crane. To avoid this, always center the hook and line over the load before lifting. Also avoid shock loading, a term used for sudden stops and starts. For example, if you picked up a load very fast and stopped the hoist, the load's momentum would continue to carry it up for a second or two, then the load would drop, putting pressure back on the cable and possibly causing it to snap. or in the case of mobile cranes, causing it to tip over. When you're finally ready to move the load, you need to consider the path it needs to take. With stationary cranes, choose the clearest, most obstacle-free path between where the load is and where it needs to be. Only lift the load just high enough to clear any obstacles in your path. Watch out for any overhead hazards that might be in the way, such as power lines. After the load's in the air, start moving it as slowly as possible to avoid swinging. Like shock loading, swinging a heavy weight can overload the crane and cause an accident. Do the same when stopping the load. For mobile cranes, such as crawlers or truck cranes, the boom must be carried in line with the direction of motion, either straight back or forward. Unless there's an operator in the cab or the boom is supported, the superstructure needs to be kept still. Empty hooks must be secured during travel, and a designated person must determine safe positioning of the load, the boom's location, the travel route, and the crane speed. Whether a crane is loaded or not, the boom must not be positioned high enough that it may bounce back over the cab. The biggest danger when using a crane is crushing someone or being crushed yourself with a falling load or a piece of the crane. If you're operating the crane, never move a loaded crane over people for any reason. If the crane breaks down and the load can't be removed and gets suspended in midair, don't let anyone walk or work underneath the load unless it's secured in place, or some sort of support can be put underneath the load. Of course, you should never walk underneath a load yourself, whether it's moving or suspended, and never ride a suspended load. Never leave a suspended load unattended. Make sure an operator is by the controls at all times, or lock out and tag the controls until the crane is repaired. Before you can operate any cranes on your work site, you'll need to be trained over the specific crane you'll be working with. You'll have to take a written test over your crane's controls, calculating your crane's load capacity, any procedures for avoiding power lines and other hazards on the site, specific procedures for moving and operating cranes and loads onto the site, and other specifics about your work site, such as the characteristics of the ground or other surfaces the crane will sit on. You'll also need hands-on training over how to inspect your crane, how to operate it, how to interpret your crane's load chart, and how to shut down and secure your crane when it's not in use. Your employer will make sure you receive this training before you'll be authorized to use your crane. There are a few other things to keep in mind when working with or around cranes. Never cross a crane's path or walk under its load. Don't operate cranes or hoists without the manufacturer's recommended amount of ballast or counterweight. Truck cranes can be operated without a counterweight, but use caution and only do this with light loads. Keep the operator's cab clean and orderly, and make sure all equipment and accessories are properly stored. If you need to use portable containers to refuel cranes, only use approved safety cans with automatic closing caps and flame arresters. Never refuel portable cranes or hoist machinery components while engines are running. Finally, an approved, fully stocked fire extinguisher must be kept in or near the crane's cab at all times. Operators will need to be trained on firefighting procedures, including how to use the fire extinguishers present near their crane. Lesson 5. Identify types of crane attachments. There are several types of crane attachments for lifting different types of loads, including C-hooks, sheet lifters, pallet lifters, spreader beams, and chains. Each device carries its own set of dangers. C-hooks are hoist attachments generally used to move coils of material. The bottom of the C slides into the center of the coil, and then the crane operator lifts it. When using a C-hook, always center the lifting point above the center of the coil to balance it. You should always stand next to the closed side of the C-hook. If you stand on the other side, there's a risk the coil could slip off and you could be struck by the coil. As the name indicates, a sheet lifter is an attachment designed to lift sheets of material, such as metals. When using a sheet lifter, always grab the sheets along the longest edges of the rectangle. If you pick them up the other way, there's a good chance the sheets will bow in the middle and fall out. The gripping teeth on the underside of the lifting surface should be all the way under the sheet edges before you lift, and the sheet side should be straight against the lifter's sides. Never let anyone stand at either open end of the sheet lifter. If the crane swings the lifter too hard, a sheet could come loose and fly into anyone that happens to be standing on that end. Spreader beams are used to distribute the weight of loads along a beam, giving the load greater stability. The main drawback to spreader beams is that you need a lot of headroom to use one. Balancing loads can also be tricky, so as always, take the time to lift the load a few inches to check the weight distribution and make sure it is even. Chains are another versatile tool for rigging odd-shaped loads. Be careful to inspect chains before use, checking for elongated, bent, worn, or damaged links. When storing chains, try to hang them up out of the way so they won't get wet or run over by heavy equipment. If there's any visible damage to a chain, you should take it out of service right away. You should be able to identify types of cranes and the types of inspections required on cranes. You'll also be able to identify employee roles and hand signals during crane use, safe practices for rigging and loading, and types of crane attachments.